Now, when we do calculations or work with numbers in any sort of science, especially chemistry or physics, we have to have what are called units, but we also have numbers that go with them. Now, usually what we do is we will measure some sort of number. Here we have 3.20, and it needs to have a unit. In this case, we will have centimeters. So this right here is a measured number. It's measured. In other words, I had to pull out a ruler and I actually had to measure it. Now, you have a unit that's attached to it. This is a unit. And it is, since it's C for centi and M for meters, this is a 3.20 centimeters, which would be roughly a little over an inch. Now, when we do calculations, and when I was in your position, it was hard for me to understand why it was so important, was if we just said 3.20, let's say times 4.18, or just 4.18, and we get a number, and we do a calculation. I pull out my calculator, and I put it in my calculator. I said 3.20 times 4.18, and I get 13.4. Now, when I was first taking chemistry and I did calculations, I was like, well, we know what we're talking about here. That's centimeters times centimeters, which means, my answer, we know what the answer is. It's centimeters squared. But without units, you have no idea what you have there. And so this could have been 3.20 centimeters like up here, but this might have been um, grams per milliliter or something along those lines, and you get some sort of something else over there. And so you have to have units to be able to know what it is, because this could have been, coincidentally, this could have been 3.00 feet times 4.18 um, centimeters per foot. And we could have, and then that would have been this. And of course, I'm just making up these numbers as I go along, but the point is, you get two very different answers if you assume that this is centimeters, and this is centimeters squared. And it just depends. So whatever calculations you do, keep in mind that as you do calculations that you must always use units. And we will have what are called paper labs, and these paper labs, you got to use units to be able to tell what it is that you're doing. Okay, now let me go ahead and start up another one over here. Now we have units. Now we're not going to use English units. English units are painful to use, and that's because if you don't already know, there's 12 inches to a foot, or there's like 2 cups to a pint. And these are very odd because they're very difficult to put into a calculator. Calculators do things in decimals. Okay, so, and not only that, a US gallon, for instance, is not the same as a British gallon or an imperial gallon. They're not the same. A British gallon is a little bit bigger than a US gallon. And so you have to have some sort of unified system of units so that everybody knows what you're talking about, regardless of where you're at. And that's where we came up with something called the metric system. And all metric means is it's powers of 10. In other words, you got 1, 10, 100, 1,000, so forth, onto like a million. These are all powers of 10. And this makes life a lot easier than trying to remember that there's 12 inches to a foot, or that there's 3 feet to a yard, or that there's 16 ounces to a pound. with the metric system, all we need to remember is that we have everything is in units of 10. And so that's what makes metric system metric. Now, we have something called SI, which is System International, or the International System of Units, and it is powers of 10. And I've seen this presented as somehow special, but SI is metric, all right? But you also have just metric, which is convenient, okay? And so there's lots of different metric units, but SI has a specific unit for everything. And so the first thing that we have is length. And that's how far you go, or that's how long something is, or how whether it's across campus, 1,000 meters, so that's a whole kilometer, or whether we're talking like the size of an atom, which is like 10 to the minus 10th meters. Okay. And so the meter is SI, and we abbreviate that with little m. All right. Now, with metric, which is often presented as being totally different from SI, um, sure enough, you can use a meter for metric units, but a meter may not be all that convenient. It depends upon what you're measuring. And so a centimeter, if you're trying to measure someone's height, a person can be like 171 centimeters or 1.71 meters, and it just depends. And if you're looking at really small things, it might be a millimeter, which is a tenth of a centimeter. And then you have, say, getting really down there, you have micrometers. That's a funny looking mu. That's a micro. And so forth on the line. And then you start getting down to subatomic level, and you have what are called nanometers, which is 10 to the minus ninth meters. That's what a nano means. And so of these, the SI unit is meters, but you may be able to use other units that are more convenient. Now, they're still metric. They're just not the SI unit, okay? Now, for volume, now this gets a little tricky, and you have to think about it for a second. If we have volume, volume is the space occupied. And we have to be very careful because we're going to do something else as far as mass goes. With volume is space occupied. Now, if you think about it, what would be the units for volume? Well, I asked this in my face-to-face classes, and some of the more clever ones will say, "Oh, that's got to be a liter." Well, that's great. You can get a 2-liter Coke, and if you take the container of a 2-liter Coke and you split it in half and visualize it, well, that's a liter. But no, that's not it. And then they say, "Oh, it's got to be a milliliter," and I put it over here, metric. And a milliliter is pretty convenient because it's about the size of a marble. It's 1 centimeter by 1 centimeter by 1 centimeter. But in reality, because it's volume and we're stuck with the length as being SI, well, how do we calculate the volume of a regular object? Well, we say length times width times height. Now, if we substitute in meters times meters times meters, because that's the SI unit, what do we get? We get meters cubed. And so the SI unit for volume is actually meters cubed. And it has to be. It has to be, because if you think about it, if you're measuring the edges of a cube, you have to use meters if it's SI. And what's meters times meters times meters? It's meters cubed. Now, that's a pretty big box if you think about it. That's a little over a yard on each side. And that is a big box. Now, if we're trying to decide the volume of water behind a dam or laying concrete, well, maybe a cubic meter works pretty good. But if we're working in a laboratory, generally you're going to be working in liters and milliliters, and even for nursing types, you're going to inject in terms of milliliters or what's called cubic centimeters, which by the way is exactly the same thing, or cc's. These are all the same. A milliliter is a cubic centimeter, which is a cc. And by the way, if you didn't know, cc is short for, guess what, cubic centimeter. And so if you're dealing with smaller quantities, you might have a microliter, which is 1,000th of a milliliter. So you have micros and nanos and whatever, okay? And so milliliters, yep. Milliliters is a thousandth, and a microliter is a thousandth of a milliliter. In other words, there's a lot of microliters in a liter. Okay. Now that's length and volume. Now mass, that is the amount of matter. And the interesting thing about mass is that where we have like meters cubed, and then we have like centimeters and millimeters and microliters and so forth. The interesting thing about matter is that the metric unit is actually the kilogram, and a kilo means 1,000, so it's 1,000 grams is a kilogram. And I say that because, why not just make, a gram the size of a kilogram? Well, it turns out grams are pretty convenient size. And so sure enough, the kilogram is metric. It's a kilo, that's 1,000. Kilo of anything is 1,000. And so, but more conveniently, if you're working in like a laboratory setting, you're going to use grams, or you might use milligrams or micrograms. And so it just depends. Okay. This is probably the most common usage for grams in the metric system, but kilograms is the actual SI unit. So you can have somebody who weighs, you know, 220 pounds, and that's 100 kilograms. And you say, well, that's a 100-kilogram person, 220 pounds. And particularly with things like drug calculations, you may weigh a patient in terms of pounds, but you have to convert them into kilograms or grams to actually do the drug calculation, because most things are done in metric units. And so we have length, volume, and mass. Then we have temperature. And it is actually, for the SI unit, it is something called a Kelvin. And it is big K. Now, usually if I ask people, I say, well, what's the metric unit for temperature? They would say degrees Celsius. And sure enough, you can use degrees Celsius. The problem is that if you use degrees Celsius in some calculations, it won't give you the correct answer. And the reason is Kelvin has no negative numbers. More on that a bit. There we go. Kelvin has no negative numbers. And in certain calculations, particularly gas law calculations, if you have negative numbers, you will get very unreal numbers, such as negative volumes and negative pressures, which there's no such thing. And so, but degrees Celsius is still metric. It's just that many calculations you can use degrees Celsius, but you can't use them in all of them. And you're generally safer using Kelvin in calculations involving chemistry or physics. All right. And finally, we have time. And it is the second. And you may say to yourself, well, wait a minute now. Can we have metric that's not SI that's in seconds? Well, ask yourself this, how many seconds are in a minute? 60. That's definitely not metric. How many minutes in an hour? 60. How many hours in a day? 24. And how many, days in a year? 365 and a quarter. That's a quarter because, the earth doesn't rotate exactly 365 days. And so in metric, it's still seconds. Um, but it's not unusual to say like per hour, like kilometers per hour, and we just kind of ignore that. But generally speaking, your SI units have to be for time. They have to be in seconds, because anything else like minutes, hours, days, years, those are not metric. Okay. All right. So there are our units that we're going to use. Now the textbook goes on to things like candelas for illumination, light intensity, amperes, things like that. That's going to be more like if you decide to take physics, you'll worry about those there. But these are generally the units that we're going to use for the vast majority of our calculations. This is length, and we're going to use the metric system over here. We're not going to worry too much about the SI units, but it's important to know which ones to use. And like I said, there are going to be situations where um, you have to use SI units, particularly with gas law calculations, and there's a couple others, but mostly it's the gas law calculations where you have the trouble.